Good morning from Fours. How are you guys doing? You guys are great, yeah? That's fine. I think this is the first lesson in this week, and coming out straight from the weekend. I hope you guys are doing fine. Okay, just stay home, stay safe, just follow the measures, and yeah, just keep it up. So last week we were looking at covalent bonding, and we said it is a bond which exists between two or more nonmetals. Now, today we'll look at covalent compounds, okay, which are compounds that have covalent bonds within them. All right, so let me start off by just reading in the book. It says a huge number of compounds also exist as molecules. Now, remember we said molecules. Okay, a molecule is whereby two or more non-metal atoms have joined. Okay, through sharing electrons. So what you have is a molecule. Okay, when you say a molecule, you mean that. Now they say in a molecular compound, atoms of different elements share electrons. You see, so in a molecule there is sharing of electrons, and we do know that if it's all about sharing electrons, it means this happens between two nonmetals. There can be sharing of electrons between a metal and a metal. When it's a metal and a nonmetal, then it simply means that transfer of electrons. Now they say the compounds are called covalent compounds. Here are three examples. So we'll see three examples of covalent compounds. The first one is hydrogen chloride. Okay, did you know that hydrogen is a nonmetal? Yes, it is a nonmetal. It exists as a gas at room temperature. And we have chlorine, Cl, which is also a nonmetal, which exists as a gas at room temperature. Now, hydrogen has one electron in the outermost shell, and chlorine has only 7 electrons in the outermost shell. Now, when they share one electron each, when each contribute one electron, it simply means, do you see in the intersection part of the shells, you have an X and a dot. That X is the electron for the hydrogen, and the dot is the electron for the chlorine. Now, the fact that those electrons are in that intersection, it simply means those electrons are flowing in the hydrogen and also flowing in the chlorine shells. Now it means two electrons are flowing in the hydrogen, making it have a fully filled outermost shell. Since it's the first shell, so if it has two electrons, it simply means it is fully filled. Now, if you see on the other side where there is chlorine, you can see that those two electrons as well, the dot and the cross, are also orbiting. They are also orbiting the chlorine shell. But besides that, you also have those 6 dots. Those 6 dots are the electrons for the chlorine, meaning to say you have 6 chlorine dots, which are electrons flowing only in the shell of chlorine, and you also have 2 electrons which are also flowing in the shell of chlorine, also flowing in the shell of hydrogen. If you make it up, the total is 8. Now let's just look at this right up right here. They say the chlorine atom shares 1 electron with the hydrogen atom, as you can see in the overlapping section. Both now have a stable arrangement of electrons in the outer shells, 2 for hydrogen and 8 for chlorine. Okay. All right. Oh, that was so much explanation. I'm running out of air. Alright, then we have water right here, H2O. Now, you can see that they call it a molecule of water because all the elements that make up this compound are nonmetals. You can see you have hydrogen, then you have another hydrogen, and an oxygen, which all of them are nonmetals. Now you can see that in the first hydrogen, on the left, it has an X as its electron. It is sharing with one of the electrons with oxygen. Then on the other side as well, you have an X, which is the electron for hydrogen, sharing with one of the electrons with the oxygen. If you do a count up, you can see that this hydrogen on the left has 2 electrons in its outermost shell, and the one on the right also has 2 electrons in its outermost shell, and the oxygen has 8 electrons in the outermost shell. Now let's go to the right up. It says the oxygen atom shares electrons with the 2 hydrogen atoms. O now have a stable arrangement of electrons in the outer shells, 2 for hydrogen and 8 for oxygen. Okay. Now let's see the third example of covalent compounds. Now we have methane. You call it methane, no problem. But let's call it methane because it's a methane. Alright, so methane is made up of carbon and hydrogen. And did you know that carbon is carbon is an non-metal? Yeah, carbon is non-metal. And you have hydrogen, which is also non-metal. So they call it a molecule of methane. Now, as you can see, carbon has 4 electrons in the outermost shell. So it shares 1 each with another electron with hydrogen, such that all the hydrogens have 2 electrons in the outermost shell, and the carbon has 8 electrons in the outermost shell. Alright, it says right here, the carbon atom shares electrons with 4 hydrogen atoms. All now have a stable arrangement of electrons in their outer shells, 2 for hydrogen and 8 for carbon. Alright, so it's about the shapes of the molecules. Okay, let's skip that. Let's just follow the syllabus. Let's not get carried away, It says more examples of covalent compounds. So they say this table shows 3 more examples of covalent compounds. Each time the atoms share electrons to gain stable outer shells. Alright, so that's the first thing about covalent compounds. The atoms in the compound, they share electrons, okay, to become stable. They don't lose or gain, they just share. Repulsion between pairs of electrons dictates the shape of the molecule. We'll talk about that later. But for the meantime, let's look at this covalent compound, ammonia. So ammonia is